I met him 7th period because I got here and he was still here. Alright, ready? I don't know what that was. Yeah. Okay. Alright. Tristan, we ready? Sean, we ready? Yes? Ready to go? Okay. Look at the top. You are going to learn how to do all the stuff that we've been doing dx now with dy. So, first thing, your cross sections will be taken perpendicular to the y-axis. Yes, sir.
Good.
Okay, then your integration boundaries are going to be y values. Okay, so the numbers that go here and here. Okay, those are going to have to be y values. Okay, and then it says your equation has to be in terms of x equals y stuff. And then the base of your region is going to be right minus left. Okay, and then your volume, how do we get volume if we have area? We integrate it. Very good. So volume equals the integral of a of y dy from c to d. A of y dy from c to d. Now, remember, area is what a of y stands for. So if you don't remember, that's the area of the cross section. Okay, and then remember that the area of the cross section could be a rectangle, square, triangle, ellipse, or semicircle. Okay? So, number 2, graph it. Okay, it says we want y equals 3x squared, the y-axis, and y equals 12. So let's graph that first. So y equals 3x squared is going to look like that. Y equals 12 is going to cut across like that.
But why did you CD instead of AB?
Because those are y values now. So usually a to b are your x values, and c to d are your y values. Okay, now, they give you a third side. What does it say the third side is? The y-axis. So when I shade, I can only shade from the y-axis over that matters. Okay, from here, look at the second thing right here, or the third thing. It says your equations must be written in terms of y, which means that it's x equals. So if I look at the equation that they gave me, I can't use that. What I need to do is resolve that for x equals. So if I have y equals 3x squared, I need to resolve for x equals form. So think about it. The first thing I'm going to do is divide the 3 over. So I'd have x squared equals y over 3, right? And then what would I do after that to solve it? Square root. So x is going to equal plus or minus the square root of y over 3. Now, quick question here. Remember that when you take the square root, okay, technically you have 2 branches. If I want the branch in this quadrant instead of the branch in this quadrant, do I want the plus or the minus root?
Plus.
The plus, because it's on the right side, right? If it was the left side, I'd pick the minus. So this is x equals the square root of y over 3. And I'm going to write the positive, but you don't have to put it. If you don't put it, it counts as positive anyway. Now, in addition to the AP test maybe wanting to trick you, okay, the question is, why do they keep giving us equations in y equals form if they need to be in x equals form? This is why. If they gave you that, would you have known what it looks like? Probably not. So they're giving them to you in y equals form because most of the time y'all can graph those easy versus the x equals maybe you couldn't graph. So they're going to give it to you probably in y equals to assist you in sketching the graph. Okay? Alright, so go down to part B. says set up an integral to represent the area of the region. So if I want the area of this region, I would say A equals the integral from where to where. Give me y values. Okay, 0 to 12. And then remember that my area is found by doing the right border minus the left border. What is the right border?
12.
Are we going to call it 3x squared? We're going to call it square root y over 3. Positive, yes. You don't have to put the positive though. Okay, so that's the right side. What is this left side? 0. dy. Done.
Why do you put minus 0?
Just to show that it's right minus left. If you didn't put the minus 0, obviously you wouldn't get any points off. Okay, now go to part C. Instead of area, now we want volume. So the first thing that I want you to do is draw your cross section. It says that it should be perpendicular to the y-axis. So if the y-axis is this way, then perpendicular to that is this way. So I'm going to do a little arrow down here and put base equals. And notice that instead of your base being a top minus bottom, now it runs sideways. So I'll do right minus left. So it'll be y over 3 minus 0. Okay, but remember that now it's right minus left.
Will the base always equal the area from the part B?
It'll always equal what's inside the area from part B, yes ma'am. Okay, so from here, what shape did they give you? Okay, very good. It says a square cross section. How do you find the area of a square? B squared. And then I just take this, plug it in here, and then remember to turn it into volume, I have to integrate it. So it would be volume equals the integral of my base squared dy, but then my base is really only the square root of y over 3. Now, what should my endpoints be? 0 to 12, because those are the y values. Now, on the AP test, if they make you do an integral by hand, usually they'll make it so that stuff crosses out with each other. What's going to cross out here so that we'll be able to do it by hand? The squared and the square root are going to cross out. So really, this is just the integral 0 to 12 of y over 3. Yes? Does that make sense? And then from there, you can do it by hand. So we're going to work this one all the way out. But keep in mind, they do stuff like this on the AP test to make it work. So, y over 3, what's the antiderivative of that? Y is going to turn to a squared. And then I have to put a half next to this third, a sixth. Now, Yoel, what should I put around my antiderivative so that I don't lose a point on my next quiz? Yes, brackets. Good. Okay? Then from there, we're plugging in 12 and 0. Now, when I plug in 0, what am I going to get? 0. When I plug in 12, I'm going to get a sixth of 44. Sorry, 144. And then I don't really know what that is. Don't really care. It doesn't matter. So then from there, you do top minus bottom. So your total volume would be 144 over 6. Okay?
24.
Perfect. Okay. No.
So put brackets around.
Yes. Okay, can we turn the page?
Don't cry.
Yes, don't cry, Yoel. It's okay. If you need someone to talk to, I'm here for you. Okay, good. Turn the page. Yes? Okay. Okay, we are going to jump down to number 4, then we're going to come back to number 3. So take a look at number 4. Notice that this one is graphed for you, but we're going to do it without the calculator. The first thing that I want you to do is retrace which of these is 6y squared. Okay, I want you to think about that for a second. 6y squared is a parabola opening to the side. So which branch of this, is it the top or the bottom?
The bottom.
It's the bottom. Okay, this is why your graph should be symmetric, right? So if this one is 2 away, this one needs to be 2 away. So these branches are the x equals 6y squared. Okay, and then on the other side, if it's a cubic graph, then that should make sense why it's shaped like that. Okay? So this one is x equals y cubed. Okay? So first thing says find the volume of a solid whose base is bounded by y cubed and 6y squared with the indicated cross sections perpendicular to the y-axis. Before I start, what's the first thing I need to do? Find the intersections. And how do you find the intersections? Set the graphs equal to each other. So I'm going to let y cubed intersections. I'm going to let y cubed equal 6y
Do
squared.
you have the right intersections or can you just
No.
put them together?
Just put them equal on the AP test. Okay, now what would I do to solve that? Can I divide by y squared on both sides? No. What do? You get everything on the same side and then factor. So I'm going to bring this over here. So now I'm going to have y cubed minus 6y squared is 0. And then what do I notice? I can factor out of both of those, a y squared. So that's going to leave me with a leftover y and a minus 6, which means that these cross at 0 here and 6 here. Okay? Then from there, I'm going to write my base into my graph. I'm going to draw it. So I have to draw it. Huh?
It looks like they cross at 8, but it don't look like they cross
That's not an 8.
No, look, move your finger down. Move your finger down. Yeah.
Yeah, this is the x value. Yeah, so this point is 8 comma 6. But the problem is that, do you notice they gave you the 8, they didn't give you the 6 because that's what you needed. Okay, so be careful about that. Just because they label something, you want to make sure that you're looking for the right things. Okay, so my base is going to be perpendicular to the y-axis, which is this way. And so when I draw my base in, I notice that it's running sideways. That means it's a right minus left. So look at the base that you drew. What is on the right side of that line? Okay, base equals 6y squared minus, and then what's on the left side of the line? Y cubed. That's how the base, how the cross section runs. So see where it says perpendicular to the y-axis? So I'm drawing a line that's perpendicular to the y-axis. Okay, so this is my base, right minus left. Okay, from here I want rectangles whose height is half the length of the base. Well, area of a rectangle is base times height, but if the height is half the length of the base, how would I rewrite that?
1/2 b squared.
Okay, very good. Base times half the base, which is half base squared. And then how do I get to volume if I know the area equation? Integral. Okay, but your endpoints this time should be y values. So I'm going from 0 to 6. And then I want a half base squared. If you remember, you can put the half inside or you can put it outside. It doesn't matter. So half base squared, and then that's 6y squared minus y cubed dy. Now, one like that, they would probably not make you work that out by hand. Okay? Okay, part B. Isosceles right triangle with the hypotenuse as the base of the cross section. Before you start, I would write the area of a triangle. It's what? 1/2 BH. And then I'm going to draw the triangle with the hypotenuse as the base. So, we need an isosceles right triangle. There's my right angle. But I need the hypotenuse to be the base. So that tells you that you want the right angle to be pointed up. Okay? The top. Now, when I draw this, we know it's isosceles. If two sides match, what else has to match? Two angles. Which means if this is 90 and these match, what type is it? 45, 45, 90. Now, here's the problem. When you do your area formula, it has an h in it. That h has to go. So remember, what we learned yesterday is we're going to draw the h in, and then we're only going to look at the triangle one half at a time. So I'm going to pretend like this half isn't there. This is my base. Now, my upper angle used to be 90 degrees, but I just cut it in half. Now it's a 45. So I'm going to redraw a little baby picture of only this side over here. So boom, boom, boom. This one's now 45. This one's now 45. Then what do I know about these two sides? They have to be the same. And so if this side is halfway across the base, what is this side? Half the base, half the base. Which means that in my original formula, when I need to know the height, I'm going to replace height with half of the base. So it'll now be this. Half b times h, where h is half of the base. And that'll reduce to a fourth b squared.
I'm confused. Why did you put 1/2 b?
Okay, so look. Here's my big triangle. And then I drew the height in, and it cuts my big triangle into two half triangles. So this side here is my height. This side is my height. But then when you cut a 45, 45, 90 in half, the result is another 45, 45, 90. Because the top was 90, so now that's 45. That's 45, that means these sides match. So if this is half of the base, and my picture sucks, but these should be the same length. Then that means that if these are the same length, then these have to be the same length. Okay? Alright, so from there, we know area, we need volume, so we integrate it. So it would be volume equals, I'm going to put the fourth on the outside this time. And then it'll be from 0 to 6. And then my base, 6y squared minus y cubed squared dy. Make sense? Okay. Alright, go up to number 3 now. Okay, set up the region for number 3. Now what you should notice, this is the last one on your notes, is that your equations are in y equals form. Why do they do that? To help you graph. But then you're going to have to change them into x equals form. Okay? So when I look at my y equals x squared, we know what shape that is. Okay, that's a quadratic. It opens up. Okay, y equals 0 is going to run flat across right here. It could call it either one. And then x equals 4 would be here. So hopefully you can see your region. If I want to be touching all three of those, I need to be here. And then the very next thing that I'm going to do is I'm going to rewrite my equation out of y equals form back into x equals form. So if y equals x squared, then what does x equal? The square root of y. Now technically it's plus or minus, but this is the positive root, and then this side is the negative root, and I want the positive root. So I'm going to come over and label square root y into my picture. Okay, now the other thing I'm going to need are my intersections or the endpoints of my region. Okay, how low is this side here? 0. How high is this side here? Do I know it? No. How do I find it? I take my equations, I set them equal. So to find this intersection, I'm going to let square root y, which is what x equals, equal 4, which is the other x equals. So remember, you can only set those equations equal to each other if they're equal to the same letter. So I need to let this one and this one be equal because they're both x equals. Okay? So square both sides. Y is what? 16. Very good. Okay, so next thing that I'm going to do is draw my base. Remember that your cross section is going to run either perpendicular to x or perpendicular to y. This one says we're perpendicular to the y-axis. So if the y-axis is up and down, that means that my region runs this way. So it'll be here. And then I'm going to write that my base equals right minus left. Which graph is on the right? X equals root y or x equals 4? Who's on the right side of my region? 4 minus root y. And that's your base. And no matter what shape they pick, that's still the base because that's the distance across your region. Okay, first one is squares. How do you find the area of a square? B squared. Then what's my volume? The integral of that, right? What are my endpoints? Is it 0 to 4? 0 to 16. Remember, they have to be y values. So 0 to 16 dy. Okay? Equilateral triangle. Do we need to rework that one back out? Probably. Okay, equilateral means it's also equiangular. And so if you take 180 degrees, you divide it into 3 equal angles, they're all 60. This one's 60, this one's 60, this one's 60. Now, when you find the area of a triangle, it doesn't matter what kind it is. It's 1/2 base times height. But my job is going to be to figure out how to rewrite the height as a B thing. So, draw your height then right here. And then remember, we're going to cut that triangle in half and pretend that this side isn't there. So we're only looking at half of it at a time. So here's my little half side. This is H. Now my top angle used to be a full 60 degrees. How much is it now? It's only 30 degrees now. And then my angle down here is still 60. Now I want you to think about the ratio of your sides. Okay, if this is equilateral, that means all 3 of these match each other. This is the base. Then how long is this? The base. And so if this is the base, how long is the short side? Base over 2, or half of the base. Because remember, that's the ratio for specials, is the hypotenuse is double the short side. Okay, so if this is half base, then what's the height? Half base root 3. And remember that that's your special rights for 30, 60, 90s, is that it's x, 2x, and then root 3 times x. Okay? So then I'm going to rewrite this here, 1/2 base, and then 1/2 base root 3. Okay? And then when you multiply that together, you want to keep all your constants in the same chunk. So half and half is a fourth, times root 3 is root 3/4. And that's your area formula. Now, if you want to try to memorize all of these, you can, but it's probably a waste of time because you don't know what shape you're going to get, and it might not even be one of these. So I would just remember how to find them is probably your best bet. Okay, volume equals integral where to where? 0 to 16, because those are my y values. Then I have root 3 over 4. And then my base, which was 4 minus root y squared dy. They would not give you one like that to have to work out by hand. Okay, that would be too much. I mean, technically could it be done? Sure, but they probably wouldn't make you. Okay? All right. 2 more left are circles. We need a semicircle and then a semi-ellipse. How do you find the area of a semicircle?
1/2 pi r squared.
Okay, good. 1/2 pi r squared. And then remember that our job is to replace r with something to do with b. So if this is the base of the semicircle, then how long would just the r be? Half of that. So my radius from here to here is only going to be half of the base. And then remember, what do? I take that, I sub it in here, and I simplify my formula to where I can turn it into a integral. So it would be 1/2 pi, 1/2 b squared. Now remember, the b and the half both get squared together. So what's a half squared? A fourth. And then what's a fourth times another half? An eighth. So it'll be pi eighths b squared. And that's your area formula. Remember, to get from area to volume, you have to integrate it. So I would do volume equals pi over 8 in the front, 0 to 16, b squared dy, 4 minus root y. Good? Okay. One mo, semi-ellipse, you remember it? You all had this in the video, right?
Yeah.
Okay. So your video said that the area of an ellipse is 1/2 pi jk. Remember that j is this radius, k is this radius. Okay? So if the entire distance across the bottom, if it's the base, then how long would just this distance be? Half the base. That's what I'll plug in for j. And then k, what does it say about the height? 4 times the length of the base. So if this is the base, it would be 4 base. So it would be 1/2 pi. Then my j is this radius, which is base over 2, or 1/2 of the base. But then my height here, it says, is 4 times the base, so that would be a 4b. And then remember that the reason that this is a 1/2 b is because this is supposed to be like a radius. So you're going from the center to the side. Okay, then what's going to happen? 1/2 times 1/2 is 4th. 4th times 4 is gone. 1. Very good. Okay, because you have a 4th on the bottom, and then you have a 4 on the top. So these guys are gone. Then your area is really just what? Pi b squared. Good. And then remember, to get from area to volume, you just put an integral on it. So it would be volume equals pi on the outside, integral 0 to 16. Your b was 4 minus root y, quantity squared dy. And that would have been your answer. Okay? Okay, so rather than giving you an entire separate homework assignment, your last page are all dy's. So if you'll get out homework 3, we're going to work through a couple of them together. And then I do need you at some point to have a calculator so that you can type them in because they're multiple choice. Thank you. Wonderful. That's perfect. Okay, so you're getting out homework 3. Does anybody need it?
I left mine at home.
Okay. Go. Anybody else? You're welcome. Okay, the first one that we're going to do is going to be part D of number 2 on the front. And I did number 2 for you yesterday, almost all the way through, but then I just didn't finish it. So it's this part right here. Okay? This one. So if you were here yesterday, you should already have A, B, and C of that done, right? Didn't I do that? Okay. So part D says, resolve. Yeah. Okay, no worries. Okay, resolve the boundary equation to be written in terms of y. So I'm going to redraw my graph. Remember that it was a square root x. We did this yesterday. And then a y equals 2 here. So our region is going to stay the same. Okay, I can zoom out here and you can see. This is not changing. It's your same region. What's changing is how I cut my cross sections. So it says now my cross sections will be perpendicular to the y-axis. This is homework 3. Okay? So I'm going to come down to my graph and I'm going to think about this graph used to be y equals square root x. How will I rewrite that as an x equals? X equals y squared, right? And if you look at your graph, does it make sense that that's a y squared? Okay, yeah. So this is now x equals y squared. Okay, and then the other thing that I need is this line here. Do I already know how high that is? Look at your graph. What was that labeled originally?
2.
So this is y equals 2. But instead of being one of the sides, now that's my y value on my integral. Now, what is the y value down here going to be? If I have to stay in the first quadrant, it's going to be 0. Now, draw your base perpendicular to the y-axis. So if the y-axis is here, perpendicular is here. And so notice that instead of being top minus bottom, now it's right minus
Why does it
left.
say a rectangle where the height is the base? It's just a square.
It's half the base. It's cut off, but it says half. But yeah, you're right. Okay, so I'm going to put base equals. And then I need to do right minus left. What's this right border we said? Y squared. What's the left border if it's the axis? 0. So it'd be y squared minus 0. And then from there, I would write my area formula, turn it into an integral. Now, it says I want a rectangle. Okay, rectangular cross section. So area is base times height. Okay, but then it says the height is half of the base. So that means that my area is going to be base times half the base, which will be what? 1/2 b squared. And then to turn that into volume, I'm going to integrate my area formula. Remember, area can go, the 1/2 can go inside or outside. What are my y values for my boundaries? 0 to 2. And then if it's b squared, that's going to be y squared squared. Now, could they make you do that one by hand? Yes. What is y squared squared the same as? 1/2 y to the 4th. And so that would be a very reasonable integral for them to ask you to do. Now remember, your homework is your practice. So if you want to work through that and make sure you got it, cool. If not, then that's fine. Okay, these all pretty much say on the front just to set them up. Okay, turn the page. So that would be your area right there, or your volume right there. Okay, we are going to do together number 8 right here. Or should we do 7 or 8? Okay, 7 then first.
And then keep posted on the line.
Yeah, I'll send it. Does it annoy the crap out of y'all that I send you these videos?
Yes, it does. The only thing you want to see on your mind is homework answers.
Okay, well, I'm not going to do that.
They really help out.
Because what I could do instead is if you're absent, you just ask me for the video. But I might not reply till the next day, because if I'm not at my computer, yeah, you're fine.
Actually, wait, no. Actually, no. It really don't even matter. I just like.
Okay, yeah, just ignore it then unless you care.
It's okay.
Okay.
Or just block her.
Just say, will you pretty please remove me from your class, and I would do it. Okay. Okay, right here. Here's your region.
Check our work.
What do you need to do first? So this is number 7. Okay, Yoel is correct. Find the intersection. How do you find the intersection? Good. Okay, set them equal to each other. So if I let x equals y squared be equal to 2y plus 3, remember the way that you solve that is by factoring. So you would need to bring the 2y plus 3 over to the left, which is going to make it negative 2y and minus 3. What will multiply to 3 and add to negative 2? Negative 3 and positive 1. Which means that where do those guys cross each other? Okay, positive 3 up here and negative 1 down here. Now notice that this one, the equations were already given to an x equals, so we don't have to fix that. They're already labeled correctly. Okay, draw your base perpendicular to the y-axis. So if I want to be perpendicular to the y-axis, this is the y-axis, then my bases are going to be running this way. Okay, and it doesn't matter where you draw it. You just want to make sure that when it cuts through, you're looking at what's on the right, what's on the left. My right side is the line. My left side is the curve. So when I do my base, it's going to be line 2y plus 3 minus curve y squared. Now, the other thing I would encourage you to do, since we're typing this into the calculator, is make a note of which one's which. When you type these in, x equals y squared is going to be your y1, and x equals 2y plus 3, that's going to be your y2. It doesn't matter, but yeah, just make sure whatever order you type them in that you keep it the same in your integral. Okay? So let's do our area. What shape do we want? A square. So then if this is a square, how do you find the area of that? B squared. And then remember, to get from area to volume, I put an integral on it. So it's going to be the integral from where to where? What are my boundaries? Negative 1 to 3. And then of my base squared, which is 2y plus 3 minus y squared, squared dy.
Wait, and what's the point of the line that you already draw?
Just to show which way you're perpendicular to. So if you can just visualize it, you don't have to draw that. This is y2. It does not matter as long as it's in the shaded region. Okay? So now from here, you're typing this into the calculator. Now, most of y'all, I think, have already figured this out. Does your calculator have a variable button for y? No. So when you type it in, you're just going to use x's instead. Okay, so go into your y equals. And you're going to type in 2x plus 3 as your y2 and x squared as your y1. And again, it doesn't matter which one you put as long as you put them in the same order on your paper.
Wait, but the integral goes underneath the
Doesn't matter. It's still right minus left and it all works out. Don't overthink that part. Okay? So I'm going to hit second quit. I already have my equations typed in. Okay, then I'm going to hit math 9, negative 1 to 3. Then I'm going to open a parentheses in here. Why is my light on? What? Ah, there we go. Okay, and then I'm going to do parentheses y2 minus y1 close squared dx. Just like that. So it's y2 minus y1. It was a square, so then it's squared. Boom. 34.1333, answer choice D. Good. Okay. Look at the one right below it. The one right below it, you're going to have to use your calculator on everything. So the first thing that I want you to look at is, do those cross at whole numbers? Yes or no? No. Okay, the other thing that I want you to think about is which graph is which. Y squared over 16, what shape is that? That's if it's x equals y squared, it's a parabola, right? Which way does it open though?
Right.
To the right, because it's x equals y squared. So this one here, okay, that's your parabola. X equals y squared over 16. Okay, and then the other one is going to have to be your ln graph, which is this one here. So that's x equals ln 5y. Now, when you graph these in the calculator, question, is your graph going to look exactly like this graph? No, because what are you going to have to do with your x's and y's? You're going to have to reverse them. So in the calculator, I want you to type these two graphs in. Wherever you see a y, you're going to have to put an x. So I'm going to have ln of 5x and then x squared over 16. Ln of 5x and x squared over 16. But then when I look at my graph, it's not going to look right. Don't worry about that. Okay, ready? Second trace. Option 5 says intersect. Okay, then I have to wait for it to graph. Notice my graph doesn't look the same as the graph on my paper. That's okay. And then I try to push enter, and look, it keeps messing up. Why is it doing that?
Because you did it wrong.
No. Okay, I have to move my little arrow. Because look, if you're on ln, can you take the ln of 0? So look, I just have to bump over one spot and then it'll do it. Okay? So they don't cross at 0. Where do they cross at? 0.2005. Now, that's an x on my calculator. What is it on my paper? A y. Because remember, I had to reverse the letters. So this y value right here is y equals 0.2005. It is a y on my calculator, it's an x on my calculator, but it's a y on my paper because I had to switch them. Okay, then second trace 5, enter, and I'll guess maybe like 6. Okay, 7.6336, good. 7.6336. Okay, but sometimes people will get confused and they'll start pulling the y values out of the calculator. Remember, you don't want to do that because you switch the letters. That's why it's coming out as an x. Okay, then go back to your graph. Draw in your base. How is it going to run, it says? Perpendicular to the what? Y-axis is this direction. What is my right minus left going to be then? ln 5y first minus, and then y squared over 16. Okay, then what shape do you want? Okay, it says for this solid each cross section is a square. So it'll be area equals b squared, and then we're subbing out. So it'll be volume equals the integral of b squared. What are my y values we said? We found them in the calculator. 0.2005 on bottom, 7.6336 on top. And then remember we said ln 5y has to come first, and y squared over 16 has to come second. And then before you type it in, I would look at the order and make sure that you have your y1 and y2 labeled. So ln 5 was my first equation, that's my y1, this one's my y2. Okay? And then type it in real quick, bell's about to ring. Okay, good job, people. The last new thing is your last kind of volume, and it's next week, and then we just get to review. Nothing. You can work on, a lot of people will take like a practice test for like if you have to take a college math test or something, like A&M and UT, I think, make you do it.
Do you remember taking that math test?
Oh, yeah.
I only require one math, well,
If you pass the AP test, then this would be your math. The reason that they make you take that test anyway is because if you fail the AP test, then they need to know where to put you.
Yeah, because my
Give me your homework too, I'll just drop it on the table and I'll grab it.
signature only requires like one that class.
Yeah. Then if you pass, you'll be,
Stats. So
wait, it only requires stats?
like like stats and medicine, I guess.
Oh, are you gonna be a doctor?
Nursing. No, I'm not doing doctor.
Oh my gosh! When I'm sick, you can take care of me.
Which is this? I think I did the graphic wrong. This. Is it this?
2x negative. Yeah, that's perfect. So then that's gonna be a cusp. So you'll have to break it up into two sides.
Yeah, so is it
So
this
from
right here?
yeah, so from now hold on, it does say in the first quadrant.
Uh-huh.
So you can't start till 0
Oh, okay.
to the intersection.
And then
So then from 0 till 0.6 you'll be under the E graph, and then from 0.6 to 2 you'll be under the line. And those will be your two
it's
sides.
because I didn't know, because I was like, what point is that? So
Yeah, and that's where you have to look for. If they say the first quadrant, you know E's never gonna hit that.
Yeah.
So then that's where you'd have to think about 0 as your starting value.
what did you say which one?
Just homework 2. You just give it to me.
Oh, okay. Also,
Thank
this
you.
one, I kept trying to put it, and I kept getting it in error. I don't know,
Okay.
I think I did it wrong.
Um.
Because I put it in the calculator, and it said 1.
Okay, because this graph is wrong. This one actually should have been, it's a 2. And I think I sent out a remind, but this axis is labeled wrong. The reason why is, think about it, if you plug in a 2 there, what's negative 2 plus 2?
0.
0. That's where this should have hit. the
Okay, 'cause I was like-
x-axis. Think about it, if you plug in a 3 to that, what's negative 3 plus 2? The square root of negative 1. That's why it's saying error. It's because you can't take the square root of a negative number. Do you need me?
Yes.
Okay. Give me 1 second. Yes. That finance lady? Yeah, you can send her out. Oh, okay, all right, then you'll have to give you 2 minutes. Okay, thanks, bye. Okay, yes.
I was here to do my consultation. I did
Perfect.
it yesterday, but yeah.
Oh, yeah, I wasn't here. Have you come to a meeting?
Yes, I've been for like 3
Okay, perfect. Then can you tell me your name? And what's your last name? Yep. I do need you to put your name, $2, and then sign. What's up,
Miss
Nima?
Jenner, I need to talk to you, Miss. I just saw my grade book. So in my quiz, I already given my quiz because I saw that maybe I was absent at that day. I was present at this day, and I did.
Happy day.
I did with my group, like Mom, me, and Mariam. So they have graded, and I didn't grade it. So can you
Did you
please-
take your own?
No, I take with the group.
Well, you can't do a group for, everyone had to do
yeah,
their
we were sitting together, but I did my own thing.
own. Okay,
So I was like trying to
did you put your phone number or your name as your login?
Yeah, I did.
Your name?
Yeah. my
Okay,
name.
then during 7th period today, remind me and I'll double check. But whenever I looked at the printout, I didn't see you on there, but I'll check again. Just remind me 7th, okay?
So because like I was, you can talk.
No, it's okay.
I was like, because I was failing this class again, so I was like, I don't want to fail this class because I do my homework every day.
Yes.
So I was like, I really want to go and talk to her. Yesterday I wanted to talk to you, but I was like, I was going to the restroom and I didn't. When I came back, the class was over.
Oh, that's
So
okay.
that's why, because today is the grade, you're giving grades, right?
Well, so I'm gonna give you guys report cards on Monday.
On Monday.
Or not report cards, but a progress report on
Progress
Monday.
report.
So, today though, you guys have your quiz. Remember we reviewed
Yeah,
yesterday?
yesterday.
So then during the quiz, I'll go back and look, and you
Yeah.
can help me look to find your name. I just didn't see it, but I might have made a mistake, so I'll look.
Okay. Yeah, because I did with everyone. So Ma and Mariam have their grades and I don't have it. So I was like, let me go and talk.
Okay, yeah,
Okay,
we'll
that's
look
fine.
at it today 7th,
Okay,
okay?
yes, bye. See you.
Shouldn't that be one half base? I don't know, why is it which number 2?
Root, was that in the notes yesterday? Because the hypotenuse has to be a base. So you can't turn it, see how you have these turned sideways?
Okay, so it's this, the 1/2,
Hold on, let me see.
yeah, because that's the same.
This is the notes from yesterday?
Yeah.
Hold this. Let me see where. Period. This one. I hope I didn't make a mistake. Okay, so it was isosceles right triangle, the hypotenuse is the base. So 90, 45, 45. Dang it, I did it wrong. Why did I pick that side?
I don't know, maybe you were thinking like the hypotenuse.
Yeah, I think that I was just labeling all three sides. We should have picked that one.
Oh, okay.
So you're right, that should be a half, so that should have been a half base squared.
Okay. So it says
Because think about, like, if you're doing area, you wouldn't do 1/2 base times the slanty side. You'd have to pick that side.
Yeah.
So I just circled the wrong thing.
okay. So when it says like the hypotenuse as the base,
That
so
means
this is
the
base,
hypotenuse
so
is
that's
down.
The hypotenuse.
Uh-huh.
Okay. So then.
And so then if that's the base, that's halfway across the base. And then when you split it, that half base and that half base have to equal each other, because when you split it, it makes a 45, 45, 90.
Okay. So this is just 1/2 base.
Uh-huh. And that's 1/2 base. Just in the formula, we shouldn't have picked the root 2 side. We should have picked the 1/2 side.
Okay.
Because you want the height of that. Yes. Is it Barakchea?
Yeah.
Oh, but I can't just email it. Because, this finance lady is like coming to talk to me today. I'm so